in continuation with current electricity. Last topic we discussed resistance in series. Today we will discuss resistances in parallel combination. So resistances in parallel combination, when they are combined in parallel, how they behave. Say there are three resistors connected in parallel like this. We have three resistances, they are connected in parallel with a battery of potential difference V. This is R1, this is R2, this is R3. These three are in parallel. Now when you see that if the current passes from positive to negative, in parallel three different wires, the current divides I1, I2 and I3. And again when it comes back, it recombines to the same current. This is parallel. So we'll find out the parallel combination. I think and all of you know that 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. We have gone through this in class 10th also. Very simple. It is just the reverse of the capacitances. So we will just follow it. So consider three resistors. Say three resistors R1, R2 and R3. Okay, connected in parallel with battery of potential difference V. So all of you know that how it works. Now here if you see, as I is what? I1 plus I2 plus I3, because the current is dividing. This is the first equation. Now by Ohm's law, we know that by Ohm's law, V equal to IR, we can say I is V by R. So individually current will be I1 will be V by R1, I2 will be what? V by R2 and I3 will be what? V by R3. Okay, so we'll put it in first. When we put it in first, we'll get back the result is that V by R will be V by R1 plus V by R2 plus V by R3. Got it or not? Then it cancels out and finally the result is 1 upon R is 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the combination of the resistors connected in what? Parallel. So very easy. This is the way we are going to connect it in parallel. Now, in parallel, we have three characteristics. So, very general, parallel combination. What are the three characteristics? Characteristics. Now, three characteristics in parallel are, one is that, you know that potential difference is same. You have seen the same. Battery is applied, so potential difference is same. Okay. Second is current divides. Current is dividing. So current divides. And third is net resistance is minimum. So that is very simple. I have three resistors, say example 1 ohm, 2 ohm and 3 ohm. Now if I say they are connected in parallel like this, one is of 1 ohm, other is of 2 ohm, other is of 3 ohm, this is 1 ohm, 2 ohm, 3 ohm, then in parallel all of you know what is the resistance is 1 by 1 plus 1 by 2 plus 1 by 3. You solve it out, it is 6. Okay, and then you reciprocate. So 6 plus 3 plus 2, so then it will become what? 11 by 6. If you reciprocate it, 6 by 11 ohm. So very less. So when you connect them in parallel, this is the answer. So parallel combination of resistance is like this. Now series and parallel we have done. So I have 2-3 questions and then we will move on how to calculate series and parallel combination of the resistor. Already we have done these things in what? Capacitors, but then we have to connect it in them what? Parallel and series. Now the first question is very simple. What is the equivalent resistance between the 2 points in the given figure A and B? Now these 3 resistors are given. Now you know that there are 2 junctions across there. What resistance? So all these 3 are in parallel. If I write like this, I am going to make it like this. All 3 are in parallel. So 2R, 2R and R. So we will solve it out. One net R will be what? 1 upon 2R plus 1 upon 2R plus what? 1 upon R. So 2R will be the LCM. 1 plus 1 plus what? 2. So it will be 4 by 2R. Solve it. So it will be what? 2R by 4. So simply you get R by 2. So this is the first answer for this one. Very simple. All 3 are in what? Parallel. So you just add them and you will get the answer. Now in this case, this is an important question. What is the equivalent resistance between A and B, A and C? Now if you remember, we did this question in the capacitor also is this type of question. When we talk about A and B, then we have to leave this one, D and C. When we talk about A and B, the circuit will be like this. See here, it will be the closed circuit. When we talk about A and B, this will be the circuit. Are you getting it or not? You don't have to take C and D because they are open circuit. So always we take a closed circuit 10 ohm, 10 ohm, 10 ohm. And then this is 10 ohm, this is 10 ohm, and this is 10 ohm. Are you getting it or not? And then when you apply it, these 3 are in what? Series. So 10 plus 10 plus 10, it is 30 ohms, and you write it like this. Are you getting it? You write like this, A and B, and these 3 will give what? 30 ohm. Got it? Then this is 10 ohm, 10 ohm, 10 ohm. And then these 2 are in what? Parallel. So 1 by R dash will be 1 by 10 plus 1 by 30. So you get what? 30 here. And then it is 4. So it will be 7.5 ohm. Getting it or not? And then finally you have what? 10. Then again this is 10 ohm. The combination of these two is 7.5 and this is 10. So what is the net resistance? All 3 are in series. So net will be what? 10 plus 10. This will be 27.5 ohm. Got it or not? Again repeating, you don't have to take D and C. These 3 are in series and then they are in parallel. You got 7.5 and then they are in series. Now you have to calculate between R, A and C. So now we have to take between A and C. So we'll leave D and B. So how we are going to take? Are you getting it? This will be like this, 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 and this will be like this, and this is the A and C. Are you getting it? We leave B and D. So all are of 10 ohm. This is 10 ohm, this is 10 ohm, this is 10 ohm, this is 10 ohm, 10 ohm and 10 ohm. Okay. Now we have to get these 2 are in what? These 2 are in series, these 2 are in series. So it will be 20 ohm, it will be 20 ohm. And then they are in parallel. So when they are in parallel, so finally what we get? We always solve the closed circuit. When they are in parallel, again the result will be what? 10 ohm and it will be what? 10 ohm. Got it or not? Because this is 20, this is 20, then they are in parallel, that will make 10. So the net answer what we are going to get is across AC is 10 plus 10 plus 10. That makes it 30 ohm. So in this way, we can get the net resistance between A and C. Okay, so this is 30 ohm. Now we'll talk about the internal resistance. Now, do you know internal resistance comes in a cell? So we say internal resistance of what? Shell. Now, what is actually an internal resistance? I will just show you a simple activity that there are two cells and one is positive and another is negative end. If you see it, I will take a new cell here, and this new cell, when I put it like this, and then I take I take a small bulb, and then you know that negative terminal on this side and positive on this side, and then it glows. If you see the bulb is glowing, the current is passing through the cells. They are in series. Okay. Now you see that this bulb glows. But then when I take a old cell, this is a new one. But when I take an old cell, here if you see, the same thing I am going to do is that this is a negative, and then I am going to apply the positive and again. Okay, but this time what I see is that the bulb is not glowing. Now what it means? It means that the current is being obstructed by the cell. And why? Because I have taken an old one. Now that means this cell, which is the old one, has some what? Internal resistance. This is a new one. If you see, this is a new one and this is the old one. You can see that. So old one has something which is obstructing the cell, and that is known as what? Internal resistance. So internal resistance is represented by E. Okay. And any cell, when you draw it, is like this. You have a vessel here like this, and then you have two electrodes on it. Okay, one is this, and say another is this. One is positive and one is negative. You can take like this. This is say P, this is say N, and then they are connected with an external resistance. Okay, and the current is flowing from positive to negative. This is a cell, and inside a cell we have what? Electrolytic solution like this. There is electrolytic solution inside a cell. So cell is represented like this, and we know that the symbol of the cell is like this. So there is some obstruction through the old cell so that the current was not passing through it, but the new cell passes the current. And this is actually the internal resistance inside the cell which obstructs. So what exactly is the internal resistance? If I ask you what exactly is, so the resistance, it is the resistance offered, the resistance offered by the resistance offered by the electrolyte of a cell to the flow of current. You know that the bulb was not glowing with the old cell, to the flow of current between the electrodes. You say that the cell is discharged, but exactly what is happening inside the cell is that there is an internal resistance. So it is called what? Internal resistance. This is internal resistance. Okay. You know that this wire, this is an external resistance, but there is an internal resistance which is coming inside the cell. And internal resistance which comes inside the cell depends on certain factor. Internal resistance depends on, and that means It depends on certain factor. First is the nature of the electrolyte. That is nature of the electrolyte. Second is it is the concentration of the electrolytes. Okay. Third is distance between the electrodes. That is very important. And fourth is that is common area of the electrode. Common area of the electrodes inside the solution. So these are the factors on which internal resistance depends. We know that if any electrolytic solution is given, it will break into ion. Are you getting it? So we know that like H2SO4, we know that it forms 2H plus and do you know SO4 minus. So we know that we have an electrolytes which are depositing across the electrode and that is producing what? Internal resistance. So this is internal resistance which comes inside the cell. Now how EMF and internal resistance and voltage are interrelated. So we have one thing and that is the resistance. This is external and now I have a battery. Okay, and an internal is coming in it. This is a small r, this is capital R. So if I ask you what is the current in the circuit, now this is cell's EMF. What will be the current? I will be what? E upon net resistance, that will be R plus R. This time this is extra R which is included here. If I ask you what is EMF, you will say EMF is work done by the cell. EMF is work done by the cell in carrying a unit charge along the circuit. So that means EMF is what? The work done by the cell carrying it. And that EMF is equal to what? Two types of potential. One is V and one is V dash. Now if you ask me what is V, so V is the potential difference, okay, in carrying a charge. In carrying a charge across what? Capital R. And small v dash is potential difference in carrying a charge across, do you know, small r. So if I put it here, what will be E? IR, and this will be what? I into small r. So what it becomes, if you see, is IR plus R, and you know that you get the same thing here. I is E upon R plus R. So this is how we define. Here E is what? EMF and V is what? Potential difference. So repeating again, this will be the current in the circuit. What is the EMF? Work done by the cell in carrying unit charge along the circuit. It is the sum V plus V dash. V is potential difference across in carrying a charge across R, and potential difference in carrying a charge small across R. So this is the equation. And do you know, finally we can even say that if I put it here, E, it is I R plus IR. So if I put it here, V plus IR. So can I say that E minus V is what? IR. So this is how the equation can be written, and V is what? E minus IR. So this is the potential difference. That means if I have a cell and its EMF is 1.5 volt, do you know, if it is a closed circuit and I start measuring it across the voltmeter, after some time I may get 1.45 volt in the reading. That means 0.05 volt is potential drop across what? Small r. So V is what? Less than E here. And there are certain cases. One is that in open circuit, if the circuit is open, you know that the value of V is equal to what? E. So remember, the value of V is what? E. In open circuit, there will be no current. And then in closed circuit, you have seen here that the V is what? E minus IR. Here V is less than what? E. So this is the difference, and V is also known as terminal voltage. Remember, V is also known as what? Terminal voltage. So this is how the internal resistance comes in the cell. Got it or not? That again repeating that how this internal resistance has come. The internal resistance is across the electrodes of the cell, and then you know that it is a small r, it is the resistance of, but I showed you an activity that how the old cell is opposing the current because of its internal resistance, and then internal resistance depends on certain factors. The electrode may be zinc or carbon, what you are using, and then how the current comes in the circuit. I net resistance because it's small r. Then what is EMF? It is actually V plus V dash, the potential across is and potential across is. So the potential, you can see it, again you get this conclusion, and then finally you get a relation between EMF and what? Voltage. And then I will take a short numerical on this, and very simple. There is a question that a cell of EMF 2 volt and internal resistance, okay, and internal resistance 0.1 ohm is connected to a 3.9 ohm what? External resistance. Here connected with external R, capital R. Okay, so what will be the potential difference across the cell? So can we find out it? Yes, very easy, we can find out it. And the solution is very simple, that what is EMF is 2 volt. What is small r? 0.1 ohm. What is capital R? 3.9 ohm. What is I? E upon R plus R, you got it or not? So 2 by what? 3.9 plus 0.1. So it becomes 2 by 4. That is 1 by 2. That is 0.5 ampere. This is the current. And then can you find out the V? Yes, V is what? IR. So I is 0.5 and R is what? 3.9. So it becomes 1.95 volt. And see, very interesting thing, that V is less than E. Remember, 1.95. So I'm making like a circuit here also. Though no need of the circuit, and this is internal R. So this is small r and this is capital R. So how this question has come, you can see very simple. Cell of 2 volt EMF, internal is given and then external is given. You can find out the current and then you can find out the potential. V is IR, so V is less than E. So this is the case. We have started with internal resistance. In next class we will talk about the cells in series parallel with internal resistance. Okay, and thank you. Watch my videos regularly.